In Lesson 7.4, you will be finding the degree of a polynomial as well as writing polynomials in standard form. A polynomial is a monomial or the sum of monomials. Some special polynomials would be a binomial, which is the sum of two monomials, or a trinomial, which is the sum of three monomials. If you think of like a bicycle, it's two wheels, binomial, sum of two monomials, or like a tricycle, a trinomial, has three monomials. In example 1, it says determine whether each expression is a polynomial. If so, identify the polynomial as a monomial, binomial, or trinomial. This first example right here is a polynomial, and it's a binomial because it's the sum of two monomials. The next example, negative 6 and 5/10, that is a polynomial, and it is a monomial. This one right here, 7a to the negative third power plus 9b, is not a polynomial because right here, if you were to simplify a to the negative third, it would end up going down into the denominator. It would be 7 over a to the third. And remember, monomials cannot have variables in the denominator. So this one is not a polynomial. And then this next example, this one is a polynomial. And right now it looks like it isn't one of those special ones, but if you go and simplify this part right here, if you put the 4x and the x together by combining like terms, you would end up with 6x to the third plus 4x plus 3. So it's a trinomial. It's made up of three monomials once you simplify it. Now you may want to pause the video and try the next four examples over here on your own. Is x a polynomial? Yes, and it's a monomial. How about this one right here? Well, if you go and put these two together in the middle, you'll end up with a polynomial that's made up of three monomials, so it's a trinomial. This one right here is also a polynomial, and it's a binomial because it's made up of two monomials. In this last example, if you were to simplify this, the x to the negative fourth would go down into the denominator, and you cannot have variables in the denominator, so it is not a polynomial. The next thing you're going to do is determine the degree of a monomial. The degree of a monomial is the sum of the exponents of all of its variables. A non-zero constant has degree 0, and 0 has no degree. So that's how you figure out the degree of a monomial. Now to figure out the degree of a polynomial, it's the greatest degree of any term in the polynomial. So if you find out the degree of each piece, you take the one that is the greatest, and that's the degree of the polynomial. So let's start with example 2 here. If I want to find the degree of this polynomial, I want to first find the degree of each monomial. So right here, you find the degree of this monomial by adding together the exponents of the variables. 2 plus 3 is 5. Let me get a different color. 2 plus 3 is 5. And this right here, the number 6, a non-zero constant, has a degree of 0. So now to find the degree of the polynomial, the degree of the polynomial is the greatest degree of any term in the polynomial. So the greatest degree is right here, which makes this degree 5. In the next example, this monomial right here would have degree 3. This one, don't forget this d is to the first power, so this one would have 5 plus 1. This is degree 6. And this is degree 0. So the degree of the polynomial is 6 because this is the greatest. Now you may want to pause the video and try the next two on your own. Right here, this monomial, you might want to put a 1 for the exponents so you don't forget to count them. If you add the exponents of the variables together, you get 1 plus 5 plus 1, which is going to be 7. So this is degree 7. Now over here, this piece has degree 2 when I add the exponents together. This piece has degree 3, because 1 plus 2 is 3. Here we have degree 4, and this is degree 0. The greatest is right here, so this would be degree 4. Now the last thing we're going to do is we're going to write polynomials in what's called standard form. It's written with the terms in order from greatest degree to least degree. Then the leading coefficient is the coefficient of the first term when it's written in standard form. So if we take a look at example 3, it says write each polynomial in standard form, identify the leading coefficient. Well, we first need to figure out what degree each one of these terms is so we can put them in order. So the first one is degree 2. This is degree 5. And this would be degree 1. Now if we put them in order, descending order, the greatest to least, we're going to start out with this one, and since there's a plus sign in front of it, it's going to be positive 4x to the 5th. And then our next highest degree is right here, and that's also positive, so plus 3x squared. And then our smallest one is right here, minus 7x. Now the leading coefficient is going to be 4 because the leading coefficient is the coefficient of the term with the greatest degree. Now in our next example, this one would be degree 1 because that exponent would be a 1. This would be degree 0. This one would be degree 4. And this is degree 3. So in order from greatest to least, we would start with this one, and it has a subtraction sign in front of it. So that's a negative 2y to the 4th. Then minus 6y to the 3rd. Plus, since this is positive, plus 5y minus 9. The leading coefficient is the coefficient of the term with the greatest degree, so the leading coefficient is going to be negative 2. You want to pause the video and try the next two on your own. This right here is degree 0, degree 2, degree 4, degree 1. So now in order from greatest to least, it's going to be a positive 4x to the 4th minus 2x squared minus 3x and then plus 8. The leading coefficient is right here. It is 4. Now for the next example, this right here would be degree 1, degree 3, degree 2, degree 6, and degree 0. In order from greatest to least, we're going to put negative 7y to the 6th plus 5y to the 3rd minus 2y squared plus y plus 10. The leading coefficient is going to be negative 7. Now our last example says from 2000 to 2006, the number U of skateboards in thousands produced at a manufacturing plant can be modeled by the equation U equals 3t squared minus 2t plus 10, where t is the number of years since 2000. How many skateboards were produced in 2002? Well, if t is the number of years since 2000, if we're going to talk about 2002, we want t to equal 2 because it's 2 years since 2000. And we're going to go ahead and plug in 2 for t. So u is going to equal 3 times 2 squared minus 2 times 2 plus 10. Now we're going to go ahead and just use order of operations to solve this. One common mistake I sometimes see students make is they would multiply the 3 times 2 together first before squaring it, but there isn't parentheses around the 3 times t, so it's not the whole thing, it's not the product squared, it's just t squared. So we're going to go ahead and do that first. 2 squared is 4, so this is going to be 3 times 4 minus 2 times 2 plus 10. Now next up we're going to do the multiplying. 3 times 4 and the 2 times 2. So u equals 12 minus 4 plus 10. Now we're going to go ahead and just add and subtract from left to right. 12 minus 4 is 8, and 8 plus 10 equals 18. And now since it's in thousands, our answer is 18,000 skateboards.